Assalamu alaikum and good afternoon, Bacha. Our next lecture is on the uncertainty principle. हमने already इसको study किया Heisenberg uncertainty principle के नाम से. It's very famous. Principle कहता क्या है कि हम पोजीशन और मोमेंटम को simultaneously 100% एक्यूरेसी के साथ दोनों को फाइंड नहीं कर सकते. कैसे वो देखें पॉइंट्स में whenever one measures a position or velocity of a particle at any instant experimental uncertainties are built into the measurements. ठीक है, कोई ना कोई uncertainty जो है उसमें ज़रूर शामिल होती है. According to classical mechanics, there is no fundamental barrier to an ultimate refinement of the apparatus or experimental procedures. क्लासिकल मैकेनिक्स होता है लेकिन कोई भी ऑपरेटर्स जो है वो परफेक्ट नहीं है. हर ऑपरेटर्स की एक लिमिटेशन है. उस लिमिटेशन के बाद जो उसकी मेजरमेंट है वो डाउटफुल हो जाती है या उसमें अनसर्टेनिटी आ जाती है. सो इन अदर वर्ड्स पॉसिबल इन प्रिंसिपल टू मेक सच मेजरमेंट्स विद आर्बिट्रेरीली स्मॉल अनसर्टेनिटी. तो हम कह सकते हैं कि जिसमें स्मॉल अनसर्टेनिटी मौजूद होती है. So quantum theory predicts, however, that it is fundamentally impossible to make simultaneous measurements of particles' position and momentum with infinite accuracy. ठीक है, तो पार्टिकल की जो पोजीशन है और मोमेंटम है, ठीक है, उसको आप इन्फिनिट एक्यूरेसी के साथ नहीं कर सकते. जैसे कि मैंने शुरू में बताया कि आप 100% एक्यूरेसी के साथ पोजीशन और मोमेंटम मेजर नहीं कर सकते. So ये प्रिंसिपल किसने दिया हमें? 1927 Werner Heisenberg 1901 to 1976 introduced this notion which is known as Heisenberg uncertainty principle. If a measurement of the position of a particle is made with uncertainty delta x, x डायरेक्शन में delta x जो है वो आपके पास uncertainty है, and a simultaneous measurement of its x component of momentum is made with uncertainty delta px, the product of the two uncertainties can never be smaller than h cut by 2. दोनों uncertainties जो प्रोडक्ट है वो h cut by 2 से कम नहीं हो सकती. तो delta x into delta px is greater than equal to h cut by 2. This is called Heisenberg uncertainty principle. So delta x into delta px in mathematical form में Heisenberg uncertainty principle की. So this value is always greater than or equal to h cut by 2. That is, it is physically impossible to measure simultaneously the exact position and exact momentum of a particle. Heisenberg was careful to point out that inescapable uncertainties delta x and delta px do not arise from imperfections in practical measuring instruments. Rather, the uncertainties arise from the quantum structure of matter. तो इसको पॉइंट ये था कि quantum structure of matter that is responsible for the uncertainty. To understand uncertainty principle, imagine that a particle has a single wavelength that is known exactly. So according to de Broglie wavelength, lambda equal to h over p, h over momentum, we will therefore know the momentum to be precisely p is equal to h over lambda. In reality, a single wavelength wave would exist throughout space. Any region along this wave is the same as any other region. If we were to ask where is a particle this wave represents, no special location in space along the wave could be identified with the particle. ठीक है, तो स्पेस में जो है कोई स्पेसिफिक पोजीशन जो है उसको नहीं बता सकते. प्रोबेबिलिटी होती है क्वांटम मैकेनिकली स्केल पे. प्रोबेबिलिटी हम बताते हैं कि जी यहाँ पे पार्टिकल फाइंड करने की प्रोबेबिलिटी कितनी है. So all points along the wave are the same. Therefore, we have infinite uncertainty in the position of the particle, and we know nothing about its location. Perfect knowledge of the particle's momentum, again, this is very important. अगर आपके पास पार्टिकल के मोमेंटम का नॉलेज परफेक्ट है, यानी 100% आप जानते हैं, तो वो आपको क्या कॉस्ट करेगा? कॉस्ट इज ऑल इंफॉर्मेशन ऑन इट्स लोकेशन। तो आप उस लोकेशन के बारे में आपके पास कोई भी जो है इंफॉर्मेशन नहीं रहेगी। सो इन कंपैरिजन, now consider a particle whose momentum is uncertain so that it has a range of possible values of momentum. According to de Broglie wavelength, according to de Broglie relation, the result is a range of wavelengths. de Broglie relation के अकॉर्डिंग रिजल्ट जो है वो आपके पास एक वेवलेंथ की रेंज आ जाती है, नॉट a single wavelength. Therefore, the particle is not represented by a single wavelength, but rather by a combination of wavelengths within this range. This combination forms a wave packet. अब जो waves हैं combine होकर क्या कर रही हैं, एक wave packet बना रही हैं. As we discussed इसके हम पहले भी हमने डिस्कस किया था, wave जो waves होते हैं packet या packet of wavelengths बनाती हैं that behaves like particle. So if you were asked to determine the location of the particle, you could only say that it is somewhere in the region defined by a wave packet, because there is a distinct difference between this region and the rest of the space. Therefore, by losing some information about the momentum of the particle, we have gained information about its location or position. If you were to lose all information about momentum, you would be adding together waves of all possible wavelengths, resulting in a wave packet of zero length. Therefore, if you know nothing about momentum, you know exactly where the particle is. अगर momentum के बारे में zero information है, इसका मतलब position के बारे में 100% information है. The mathematical form of the uncertainty principle states that the product of the uncertainties in position and momentum is always larger than some minimum value. This value can be calculated from the types of arguments discussed above, which result in the value in the equation this. So another form of the uncertainty principle can be generated by reconsidering this figure. Imagine that the horizontal axis is time rather than spatial position x. We can then make the same arguments that were made about knowledge of wavelength and position in the time domain. The corresponding variables would be frequency and time, because frequency is related to the energy of the particle by E is equal to hf. So energy जो है वो hf के equal होती है. Like photon, the uncertainty principle in this form is delta E into delta T equals h cut over 2. So this is another form of the uncertainty principle. ठीक है, इसको कहते हैं energy time uncertainty principle. The form of the uncertainty principle in Korean above suggests that energy conservation can appear to be violated by a node of E as long as it is only for a short interval of time. सिर्फ short interval of time t के लिए जो है वो energy violation वो कहता है हो रही है consist with that equation. ये equation predict कर रही है कि energy violation है for very short of time. We shall use this notion to estimate the rest energy of the particles. उसके बाद देखें एग्जांपल है बहुत ही सिंपल एग्जांपल सॉल्व है. इससे रिलेटेड प्रॉब्लम्स जो हैं वो मैं आपको फिर दूंगा होमवर्क. ठीक है, पहले एग्जांपल जो है एग्जांपल आप सॉल्व करें. द स्पीड ऑफ एन इलेक्ट्रॉन इज मेजर्ड टू बी 5 into 10 raised to power 3 meter per second to an accuracy of 0.00. So example 40.6, the speed of an sound. So in example 40.6, the speed of an electron is measured to be 5 into 10 raised to the power 3 meter per second to an accuracy of 0.003%. Find the minimum uncertainty in determining the position of this electron. इसमें आपने जो है वो अनसर्टेनिटी फाइंड करनी है। तो अनसर्टेनिटी में सबसे पहले देखें आपके पास जो है मोमेंटम है। मोमेंटम आपके पास क्या है, E is equal to mu(x). सो इसमें सबसे पहले मास ऑफ इलेक्ट्रॉन 9.11 into 10 raised to power minus 31 kg into 5 into 10 raised to power 3 velocity. So 4.56 into 10 raised to power minus 27 kg meter per second आ जाएगा। Find the uncertainty. उसके बाद uncertainty in px as 0.003%. So delta px is equal to 0.003 into 00 into 4.56 और आपके पास रिजल्ट है 1.37 into 10 raised to power minus 31 kg meter per second। So delta x should be greater than equal to h cut over 2 delta px। उसकी वैल्यू अगर पुट करें 1.055 into 10 raised to power minus 34 joule second over 2 into 1.37 cross 10 raised to power minus 31 kilometer per second। तो ये आपके पास 0.386 mm जो है ये आपके पास डेल्टा एक्स की वैल्यू आ जाएगी। So with this we end this lecture। ठीक है, ये शॉर्ट से कंसेप्ट है तो इनको क्विकली जो कर रहे हैं इंशाल्लाह। तो this is not for today, इंशाल्लाह नेक्स्ट lecture के साथ टेक केयर एंड अल्लाह हाफिज़।